Hello everyone, I'm Ivan and today we are continuing talking about MAtlab, and today I would like to represent you the most important part of any code, and it is loops and switch. Without two of this construction we cannot imagine any logic in scripts or any codes. These constructors are present in any coding language. However, today we will talk about MAtlab only. Thus, I would like to talk about two types of loop, for and while. Also, we compare both of them. And we will talk about switch if. However, in MAtlab there are a few other switches, but we will talk about basic one if, which will be used in 90% of time of simple coding. Thus, let me share my MAtlab. Yep, it is already here. Sorry, I just clear all from previous and CLC. To talk about loops and switch, let's create a script and just try to put loop and switch inside of some script, and you will see the difference between them. Thus, I will create new script creation. Yes, it is here. Then, if you remember from my previous talking, I prefer to start from title of this code or title of this script, and in my case it will be MAtlab loops. Next I will add comment who is author of this duty, and it is me, just one. And also I prefer to put data stamp. Today is 21st of January 2022. And because we will run multiple times and we will use many different variables, I prefer to use two main lines in each script. It will be CLC, clear command window, and clear vars, which will clear our workspace. Next, let's create some variable x, which will be matrix with some numbers from 1 to 100 with step 5. Yep, and probably we will count some of these elements with the help of loop. Next, let's consider first type of loop, for. For construction looks like this one. Hop, and end. Thus, any loop for in MAtlab will start from for, then space, then it will be variable of loop. Here you can put any variable which you prefer. This variable will be changed during each loop iteration. Loop, it is a specific construction in code which help us to compute in cycle multiple times some part of code. And loop variable, in this case, in my case, it is a, but you can use any letter or any title of variable, will be changed from iteration to iteration. And here we need to specify the way how it will be changed. And my loop variable will start from 1 and will finish at 10. Thus, my loop will take 10 iterations, and at each iteration loop variable will be changed from 1 to 10. Then, first of all, let's try to count something simple. Just let's count sum of elements from 1 to 10. In this case, we will need to add some additional variable, for example a, and we specify that a is equal to 0, and then inside of loop we will put something like that. Variable a is equal a plus I, and then put semicolon. In this case, each time when we run our code inside of loop, variable I, it is loop variable, will be added to matrix A. In this case, I will be accumulated in matrix A. Thus, if you run it, first time, MAtlab will ask us to save it. Thus, I need to put some title, loop 2m, and you can see that sum of elements from 1 to 10 is equal to 55. And loop variable I is equal to 10, because 10 it is the last element of iteration. In order to check if it is true, let's, for example, count sum of elements from 1 to 10. Thus, a1 is equal sum. It is a function which can count sum of elements. And then we will specify our matrix from 1 to 10. And if you run it, you will see that sum of elements from 1 to 10 is equal to 55. And the same result we got from our loop for. However, usually loop for is used for much more complicated tasks than just finding sum of something. In this case, let's try to count sum of elements of X matrix. Or let's apply some trigonometric function for this matrix. In this case, loop is used in maybe 70% of time. Thus, we will specify for, then we use loop variable I, then I will specify initial or starting point for my variable I, and then I will specify how many elements in matrix X I have. In this case, we can use 3 different functions: length, numeral, or size. In just simple one row matrix, numeral will be the best because numeral has the lowest number of letters to type. Thus, function numeral will give us number of elements in matrix A, and our loop will count exactly predefined time number of times. Okay, if you type 4, remember, always put and. In this case, you will not forget about it. And if you remember about addressing in MAtlab, maybe a little bit addressing in MAtlab, you should remember that if you would like to count some variable, for example y, we need to put address of cell in which we would like to put something. And in this case, loop variable plays an important role, because we can put loop variable as an address, and in this case we will have matrix Y, and each element of matrix Y will be changed inside of loop. Okay, and here we can specify some formulas like a sine of sine in degrees from x, and in this case we also can specify that x, and we will put address I. Then we will plus 125 plus some rand value, rand 1,1 and 55 multiplied with the rand. It will be some complicated function which we will use to generate inside of loop. Okay, let's try to run it. And here you are, we've got our y variable. Just a second. Okay, we've got matrix y. Thus, how it works? Here we use, or loop variable we used for changing address of matrix in which we do some manipulation, called it like that. And it is very helpful because we can put any type of code inside of this for. Thus we can increase number of different manipulation. We can put multiple codes here. Okay, let me show you. Thus, for example, we can write d is equal sign from x addressing I, then plus cosine d x I, and then we can specify like d plus here. However, in this case you will see that we use some variable, and this variable each time will be changed. If we use only one variable, which means it holds only one number, does not matter. But if you use some matrices inside, it will be better if you use function clear and specify variable which will be changed in loop d. Thus, in this case, each time when we come here, we will clear or delete variable d, and then create it again and put this value. Then we will d add to y in some particular cell, and then y will be saved for further description. Also quite important at this stage, if you have like 20 elements in matrix, everything is okay and it is not complicated. But if we increase number of elements like 10,000, it will take some time for computation. And in this case, I would like to suggest you to have pre-allocation. Pre-allocation, it means that we create variable before we will use it in cycle. Because each time when we in loop create or increase variable, in this case MAtlab takes some time. Therefore, much more better if you operate with valuable numbers or valuable matrix, and if you would like to count it in loop, please use pre-allocation. I will add another loop in my code here, just for comparison of calculation speed. In this case, we will have the same that we have, but we will call it y1, and before we will count, I will use pre-allocation. I will add y1 is equal zeros, and I will specify one row and numeral x columns. In this case, before we will run for loop, we've got pre-allocation, and from my point of view, it should be much more speedy than our first loop. To count time, we will use function tick-tock. Thus, I will put tick here, and then here I will specify variable t1, which, maybe variable t with first value of matrix t will hold tock, which give us time between tick and tock. Thus, we will count how many time it was for calculation this loop. And also I will put tick here, and I will put tock. And I will put t2, second element of matrix T will be equal time for second loop operation. Thus, then, if we run it, we can open T. How we can do? Just putting T in command window and then printing. And you will see that first loop will computation time. It was 0 seconds 09. However, next loop it is 0 seconds 07. Thus, pre-allocation save to 20 milliseconds for our computation, and it is only for 10,000. If I will increase number of elements in my matrix, it means that I will increase number of loop computation. These numbers will arise, and difference between them will be bigger and bigger. Thus, please remember that for future, if you would like to use for loop and you will got matrices with more than 20,000 elements, please use pre-allocation for all matrices which you will change in loop. It will save a lot of time, and your code will be like a rocket. Okay, if everything is clear with the for, let's consider while and also try to evaluate speed of while operation. Thus, while it is also loop, however, this loop use condition. In this case, I will put in MAtlab while, thus while, then we need to specify condition until this loop will be run. In this case, you can put any condition, but if you would like to simulate the same task that we have, we need to specify also until I. It will be also our some variable less than number of elements x. And also at the end, we also should to specify end. Thus, our loop will be run until this logical operation gives us true. If it will be false, I will be more than number of elements x. Loop while will be stopped. Also, next, if you just copy elements that we have inside of our loop, Ctrl C, and then we put it here, you will see that we do not have I. It means that inside of while, if we would like to solve the same task, we need to enter some like iteration for I. Thus I will put I is equal I plus 1. It is like standard. Thus each time when I continue, when I will be at the end of this loop, I will increment I in 1. And of course, at the beginning, for the initial step, we need to specify I. Thus I is equal 1. And here we are. Thus let's put y3 maybe, because y1 we've got. Thus let's run. Okay, and we've got the same values in y3. Then let's compare performance of while. Thus I will put tick here and T3. It will be talk. In this case, it helps us to count how many times while will be more effective than for. Okay, and let's run it. And then let's print T. And here you are. Thus, what we have? We have first time we have 0, 0, 7. Then we've got second loop. It was a little bit longer, and our third time we've got much more. Okay, we've got approximately the same with the first one. Thus, while cannot give us more efficient calculation. Let's run one more time, and then we will print T. Okay, thus you will see that. Okay, let's run again. And let's print T. Always when we would like to run multiple times, you need to remember that we need to count statistic, and after that we can talk that for is speedier than while or some other application. But in this case, I would like to tell you from my experience that while give us the same speed than for condition in this case. Also, when we use while usually we use when we work with some performance. For example, we do not know how many iterations we need. And in this case, while will be helpful. For example, we can solve some optimization task. Thus, we do not need, we don't know how many steps we will need. However, at each step, we estimate some performance or accuracy. And if this accuracy will be met or some condition, we will stop calculation and we've got results. In this case, while is a great thing, because we do not need to think how we can apply some different construction inside of for loop. However, for many tasks, for is much more welcome, because usually we need to do something with elements of some matrix. Thus, in this case, for is quite useful. Also, in some cases, loop for may be useful for some another task, which is quite frequently used. For example, if we integrate some switch inside of for, and if after some iteration we have found that we do not need to continue calculation, thus we can stop loop for continuing, by specific indicator which called break, which means break the loop. How it works? Let me show you by usage first our loop, but I will copy it and I will use it at the end. In this case, for example, if we will be at the 5th step, could we stop execution? Yes, we could, or we can use some condition. In this case, we need to check condition, thus we need to use switch. Switch, it is another construction. We will talk about it. Usually switch in MAtlab, it is a if. If I loop variable is equal to 5, because in logical operation we use double equal, we will use a specific marker break. Okay, break. And if we also should close with end. Thus, if I will be equal 5, we will use break. Break will break loop. Thus, at the 5th iteration, our loop will be break and we will go out of loop. Let me show you. I will create matrix B, thus B is equal 1 and 0, and if we run our code, you will see that B is equal only 15 and A is 55 because I has been stopped at 5. And also you will see that loop variable I is equal 5. In this case, break is very useful when we need to check some condition. For example, we will count and we will deal with accuracy or something like that, and if we reach what we need, we can stop loop and do not continue other loop computation. Next, just few words about if construction and about main problems that someone can have with switch if, because this is also quite tricky thing. Thus, if switch, it is a switch which help us to switch what part of code will be evaluated based on some condition. Thus, we can use if, and if we put if, we need to specify some condition. If, for example, d is equal, d we've got, maybe m is equal 5, in this case c will be equal 1. Then, if you use if, of course we need to close it with the end. Thus, if variable m is equal 5, if this is true, we will evaluate code between if and end. If it is false, we will go out. Then, if we specify m is equal 3, let's check what we will have. Thus, I will run it, m is equal 3, and c variable we do not have in our workspace. Why? Because m is equal 3, if we check condition, and this condition will be false, and this line will not be evaluated. Thus, we do not have c variable. However, if you put 5, for example, here, and if you run it again, you will see that we've got C, because in this case 5 is equal 5. It is true, and we need to evaluate code between if and and. In many cases, we can a little bit improve our if we would like to specify some other condition. Thus, if m is equal 5, we will do something like that. In all other cases, c will be equal to. Thus, if you put, for example, 6 here, and if you run it, you will see that c will be equal to. Why? Because 6 is not equal 5, thus it is false. If it is false, we will do what we should to do if it is false. We will put 2 in the variable c. Also, we can add additional conditions or whatever we would like conditions. Thus, we can specify else if, and we can put m less than 3. And we can put c is equal 3. Thus, if I run it, you will see that c is equal to, because m is equal 6. In this case, it is false. It is false, thus else. If you put here 2, for example, then we run it, you will see c is equal 3. What happened? In this case, it is false, then check this one. It is true, yes, it is okay, we've done it, and stopped other comparison. Thus, first meeting condition will stop if. If we add another, like another tricky condition, else if m less 2, for example, c will be equal 4. Then if you run it, you will see that m is equal to, thus first condition that has been met give us final result, c is equal 3. However, if we make m is equal 1, you will see that in this case this condition is met and this condition is met too. Both of them is okay. Which result give us MAtlab? Let's run, and you will see that first condition will give us result, and that's all. And then switch will be stopped and go away. What is important here? Please try to remember that if it is a switch, which it is a trigger which can switch computation power of MAtlab between different parts of code or scripts. We can use like a cell for code. Thus here we can put how many lines we would like. Of course it doesn't make sense. However, we can put any number of lines. Thus here is code 1. If this condition is true, then we can specify with the help of else if other condition. Thus we can put here code 2 and multiple number of lines. And in my case it is condition 3. Thus here I can put code 3. And finally, which means all cases which will not meet in our conditions, will run code 4. This is very common case when we use if trigger. Also, please try to remember that many students or many beginners has some mistake, and they put between else and if space. In this case, everything looks like clear, but you will see that MAtlab give us red underline, which means that we've got error here. If you run this code, you will see that we've got mistake. Why we have mistake? Because it is else if, you will see. But we have mistake because in this case we use if and else. If, else, and end. This is one trigger, and in this case if, it will be another trigger. And this second trigger does not have end. Therefore, to make it operatable, we need to add one additional end, and in this case it will be work. However, it does not make any sense. Thus, I will come back to my previous code. Please take attention and always use else if, one big word, and it means that you work properly correct. Thus, we have talked about switch or trigger in MAtlab. Also, we covered for and while. Also, quite important that if in many times is used inside of some of the loop for or while. Why? Because at different iteration we need to calculate like different behavior of some formulas, and trigger helps us here, because in this case we can count loop differently, or we can mix computation lines or computation direction between variety of them with the help of this if and for. Thus, thank you very much for watching. If you have any questions, I will be glad to answer you. Waiting for your comments. Thank you. Hope to see you next.